Hello students, welcome to my YouTube channel RD Academy. So in this video, we will be discussing about section 1.11. The topic name is electric dipole. Okay, so let me start with the definition. What is an electric dipole? Now you have already seen what a positive charge and what a negative charge is. Okay, and how the electric field lines around them will be there. Now a dipole is nothing but a system of two charges of opposite polarity, that is, one should be positive and one should be negative. Okay, an electric dipole is a pair of equal and opposite point charges. Okay, that factor is important. If the magnitude of positive charge is plus q, the magnitude of negative charge must be same, but the polarity should be reversed. Okay, so the magnitude, if this is plus 1 coulomb, it should be minus 1 coulomb. So this entire system is known as the electric dipole. Okay, so I will tell the definition once. An electric dipole is a pair of equal and opposite point charges separated by small distance. Okay, the distance should be small, separated by small distance 2a. Okay, what will be the distance of these two charges now? The distance between these two charges will be 2a. Fine. So can you define electric dipole? The definition is important from your examination point of view. So an electric dipole is a pair of equal and opposite charges separated by a small distance 2a. Now it is not necessary that this distance should always be 2a. You can also take it as a. But what happens if you take it as a and this is the center of the dipole? Point O is the center of the dipole and this total distance is here 2a. Now what is the distance from the center of the dipole to the negative charge? This distance is a, this distance is a. Now if you consider this whole distance as a itself, now this will become a by 2. Then we have to deal with the fractions. So this distance 2a is standardly used just to reduce the mathematical complications. Okay, you can also take it as a or a by 4. It doesn't change the properties of a dipole. Okay, so this entire system which has a pair of equal and opposite charges separated by a small distance 2a is known as the electric dipole. Okay, now electric dipole has something known as electric dipole moment. Okay, and this electric dipole moment, the first property is it is a vector quantity. Okay, always remember electric dipole moment is a vector quantity. The second property, it is represented by the symbol small letter p, and since it is a vector we need to add one arrow. Okay, so the symbol of electric dipole moment is p vector, and the electric dipole moment is quantitatively equal to product of the magnitude of the charge multiplied by the distance between them. Okay, how will you define electric dipole moment? Electric dipole moment is the product of magnitude of the charge multiplied by the distance between the charges. Okay, and I have told you that it is a vector quantity, but here both charge and distance is a scalar. So by standard convention, okay, the third property is by standard convention, the direction of p vector is always from negative charge to positive charge. Okay, this is the other thing that you need to remember. Okay, so in this diagram, what is the direction of electric dipole moment? It starts from the negative x. This is the tail end of the vector and heads towards the positive end of the positive charge. Okay, so this vector is the direction of electric dipole moment. Fine. Now we have seen what is an electric dipole, properties of electric dipole moment. Now what will be the total charge of this system? If you can see, I have considered one dotted line, right? What is the total charge of that system? So if you go back and see the properties of charges, there is one property known as additivity of charges. So the total charge contained in a system is nothing but sum of individual charges. So here the sum of individual charges is plus q plus minus q, both of them will cancel. Okay, so that point is important. The net charge of dipole is always 0 coulombs. Okay, but does that mean the electric field of this entire dipole is always 0? No, that is not true. Okay, even though the net charge of the dipole is 0, net electric field of dipole is not 0. Okay, that is the important thing that you need to remember. Okay, now what happens at the distances very much larger than dipole separation, that is 2a is the distance between the dipoles, right? If you consider distances far away from this distance 2a, like if you have a positive charge, you have a negative charge, right? Now this distance is 2a. Now if you were to find electric field at this particular point P, this point is at a distance r from the center of the dipole. Okay, this distance is r from the center of the dipole. Now when the distance where you are finding the electric field is much greater than separation between the two charges, that is this condition, this is what we call it as a short dipole. Short dipole condition is the distance between the dipole must be less than the distance where you are measuring the electric field. At this point the electric field approximately approaches 0. Here also you cannot say it is exactly equal to 0. Okay, so these 2 points should be remembered. Net charge of dipole is 0, but net electric field of dipole is not 0. Okay, now based on this idea, now there are 2 important 5 marks questions. Okay, the first one is electric field of a dipole along axial line. Second one is electric field of dipole along equatorial line. Okay, now can you tell me which is axial line and which is equatorial line? See, any point, it can be either at this side or on the other side. Any point that is lying on the line joining the dipole charges. Here you can draw one positive and negative charge straight line, right, connecting them. If you extend them in both the direction, any point on this line is known as axial point, and this line is known as axial line. Okay, the straight line passing through the line joining the dipole is known as axial line. Now what is an equatorial line? Now if you have a positive charge and negative charge, this is dipole, okay, plus q and minus q separated by distance 2a, and this is the center of the dipole O. Okay, any point on an equatorial plane, now draw one line perpendicular to that center of the dipole. Okay, any point on this line, either on plus direction or negative direction, any point on the perpendicular line that is drawn at the center of the dipole is known as equatorial point, and that line is known as equatorial line. Now the important 5 marks question I have said is, first you need to find the net electric field at the axial line. Due to these 2 charges you need to find the electric field at this point, and also due to these 2 charges you need to find the electric field along any point on the equatorial line. Okay, so both of these questions are important 5 marks question, and I will upload both the derivations separately since there is a large number of mathematical steps. I can't upload it in single video, so I will upload it separately. The section number will remain the same for both of them, that is 1.11.1. first one will be along axial line, second 1.11.1, and it will be for equatorial line. Okay, from your board exam these 2 questions are very important, and I will explain it in the next video. Okay, so I hope I am clear in electric dipole definition, electric dipole moment definition, and electric dipole moment direction. All these factors are basics for your next derivation. Okay, so I hope I am clear in this video. We'll continue in the next video. Thank you.